Now let's talk about TensorFlow variables. We talked about tensors, which is a way to hold values, but they are constant, meaning that they cannot be changed after you create one. So variables are mutable tensors. They are tensors behind the scenes that can be changed. They can be used to hold and update the parameters of a machine learning model and also offer the ability to compute the gradients automatically. So just like a variable in math class, like x or y in a formula, and conceptually TensorFlow variables are very similar to that. Basically, when you change the values of a variable, it's able to track that automatically, and you can compute the partial derivative of a formula or an operation, a math operation, with regards to those variables. So we'll see more about that in a second, but first let's get started. The first thing we always do is import TensorFlow as TF. And then to create a variable, we can simply do v for variable is equal to tf.variable, and then we just pass in the value of the variable. So we can say, let's just do a scalar value like 0.0. And then if you want to, you could also pass in information like the data type, same thing we did with tensors. So you could do dtype is equal to tf.float32. It should automatically be inferred as a float32 data type just because we're doing a floating point value here. So we could make it 0, for example. But if we just go ahead and print out this variable now, let's see what we get. All right, here's what it looks like. So it's a TF variable. It has a shape of nothing because it's a rank 0 tensor behind the scenes. It's a D type of float32 because that's what we specified it to be. Just like before, if you want to print out important information about a variable just to understand what it holds, you can do, for example, v.shape. This will give you the shape of the variable, which is just empty, of course, because it's rank 0. You could do the data type, so D type. But more importantly, if you want to get the actual value that's held in the variable, you can do v.numpy as a function. So now if we run this, there we go. So we get 0.0. This is the actual value itself. I also told you that variables are tensors behind the scenes, and that means that you can also pass in a tensor when you're creating a variable. So we can say tensor variable is equal to tf.variable, and we can pass in a tensor. We can do tf.constant. We can do, let's just do a vector. So 1, 2, 3. And now let's just take this name here and replace it so we can see the variable details. And boom, so now we get 3 for the shape because it's a vector with a rank of 1, and it has 3 elements in that first axis. And the data type is N32 because we specified whole numbers, which makes sense. And here's the actual underlying data, which is cool. Now, of course, variables are mutable, meaning they can be changed. But if you want to change the value of a variable, we can do v.assign, the assign function, and just pass in the new value of the variable. So boom, and we'll just reprint this out. Boom. So now we get 5, and then we get 5. Oh, that's because we need to rerun this part to initialize it, and then now we get 0 and then 5. So before it was 0, we reassigned it to 5, and now it's 5. So that makes perfect sense, I think. One thing that you should know about variables is that when you're reassigning their values or changing the values of the variable, the shape cannot be changed. It has to be the same shape. So if currently it's a scalar, it has to remain a scalar value, okay? So if I try passing in like, let's just say a vector of 1 and 2, that is not going to work. So whatever shape you initialize a variable as, it has to remain that shape, okay? So besides assign, you can also do add and subtract. So you can do assign underscore add, which will add. So we get 5 and then 10. You can also do sub, so 10 and then 5. Boom, like that. So that's how you can update it that way. And let's just say, as an example, if we want to update our tensor variable, let's just say that we want to assign add to it. Like I said before, the shape has to stay the same, and that also goes for adding it because it's element wise. So if you do assign add, you need to pass in a vector of the same size. So 1, 2, 3, which lines up with the initial size of our vector. And we'll just change the values actually to make them different. All right, so now we have same shape but different numbers. Let's add them together and see what the result is. So we can go ahead and print out tensor variable dot numpy like that, and boom, so now you get 11, 22, and 33. Makes sense, right? All right, so that is how you can create variables and how you can reassign them to change their values. Okay, so now we know how to create variables and also update their values, but one of the coolest things about TensorFlow is its feature of automatic differentiation. So let's just say that we have this simple function here, y is equal to x squared. So x is our variable, our input, and then let's just say that we want to calculate the derivative of this function y with regard to x, okay? So before we continue, just make sure that you understand what derivatives are and how partial derivatives work as well, okay? If you learned about gradient descent before, you should already know what that is because that's important for machine learning, especially with linear regression, for example. That's one of the first things that you learn. So as long as you know that, you should be good to go forward with this, okay? So anyway, this is where our variables come in. So let's just say we have variable x. So x is equal to tf.variable. And the initial value of the variable x is 3. And now we want to do y is equal to x squared, so we're going to square x, okay? So we can do y is equal to x squared. And so now we need to somehow calculate the partial derivative of y with regard to x, okay? This is also known as the gradient, which I'll explain more in a second, okay? I'll clarify what that means. But to do this, what you need to do is take any operations that you did to this variable here and wrap it. Wrap it with width.tf gradient tape as tape. And then inside of here, you put any operations that you want to do using this variable, okay? In this case, we're just squaring it. And we can also just go and print out y to verify that it worked. So x is equal to 3, and then we're doing y is equal to x squared. So it produces a tensor with the value of 9. That makes sense. So the point of this gradient tape here is that it's able to track anything you do with this variable here. You can think of tape as like, on the record. It's a tape of what happened, right? Like I don't know, like a videotape, for example, right? This is recording any actions we do with our variable. In this case, we're just squaring it. And then after that, we can automatically calculate the derivative of y with regard to x, which is cool. So we know that the derivative of x squared is 2x. So if this works correctly, the answer that it should give us for this should just be 6, because if the variable x has the value of 3, 3 times 2 is 6. So that's how that should work. So let's just try this out. We'll do dy dx. So the derivative of y with regard to x is equal to tape dot gradient. So we're using the tape and getting the gradient from the tape. Now for the first one, you want the target, which is the thing that we're calculating the derivative for, so y. And then now you want the source, which is what you're calculating the partial derivative with respect to, which is x in this case. And then if you run this, now we get none. So that doesn't really make sense. There should be 6, right? And this is actually because whenever you create a variable and you want to do the gradient of that variable or the partial derivative using the gradient tape, this has to be a floating point number. It just does not work using like a whole number, for example. So just make sure you have a floating point data type. So you can do 3.0, or you can specify the D type as, float32, for example, okay? That's up to you. So now if we rerun this, now we get a tensor. So we're printing out the tensor. It has a value of 6 like we expected it to, and the type is float32. So pretty cool. That means it worked perfectly. So again, what's happening here is that we have this variable x. We are using the variable x to make a calculation, produce a new tensor. This tape here is recording everything that happens, and then we can automatically now calculate the derivative of y with regard to x, which is doy over dx. Not only does it give us the partial derivative, but it passes x into it, so it gives you the actual value itself, because it wouldn't make sense to give you a formula. So pretty damn cool if I do say so myself. This is one of the biggest things about these deep learning frameworks like Tensorflow or PyTorch, for example. They can do automatic differentiation, or also known as autograd for auto gradient, which is just really, really cool. So those terms are kind of used interchangeably, like partial derivative or gradient. Technically, there's a difference. There's a very slight difference, so don't worry about it too much. But the difference is that basically, a partial derivative is when you just have one variable like we have here. We're just getting the partial derivative of y with regard to x. But if you're calculating the gradient, this is a vector of all the partial derivatives of our function with regard to every variable of the function. So in this case, technically it is the gradient because we only have one variable x. But if we had like y is equal to x squared plus, z squared or something like that, the gradients would be all the partial derivatives all together basically, okay? But generally speaking, when you're talking about gradients though, you're just talking about automatic differentiation, all right? Speaking of multiple variables, let me give an example that is a little more complex, only slightly more complex. If we have this, let's just say we're calculating z is equal to 4x squared plus y cubed. This is obviously a calculation involving multiple variables. So the partial derivatives of the above function would be dz over dx. So the derivative of z with regard to x is equal to 8x. And then we have the derivative of z with regard to y is equal to 3y squared. So we have two different partial derivatives because we have multiple variables. We can still use our gradient tape here to get those. So let's try that out. So first we have our variables x and y. They have the values 3 and 4. It can be whatever you want. And then now we'll do our calculation. So we'll do with the gradient tape. So it's actually recorded. So tf.gradient tape. And then we're going to do z is equal to 4 times x squared plus y cubed. So we're doing the calculation, very, very simple. We're not doing anything too complex, but now we can calculate the gradient of z, which will be the dz over dx and the dz over dy. So both of the partial derivatives all calculated together. So tape.gradient z and then x and y. Just by calling tape.gradient, we're telling it what we're calculating the derivative for, and then also the variables involved, so x and y. And then we can also just print it out just to verify the values inside of it. So let's do that. So we get 24 and 48. So we know that the first one is equal to 8x, right? So if you pass an x to that, you get 24, which makes sense. And the second one is 3y squared. So if you pass in 4 to 3y squared, you also get 48, which makes sense as well. So perfect. One thing that I'll add is that you can also specify a variable as trainable. So you can add another option to this. So trainable is equal to true or false. It is true by default. All this means is that it's not going to be tracked whenever you're doing a gradient tape. So if it's set to false, it won't be tracked, meaning that you can still do the calculation. I mean, the value is still in the variable, so you can still calculate z using y. But when we calculate the gradient of z, you will not get the gradient of z with regard to y. So now we get an exception. We still get 24 for the first one because this one is still trainable, but the second one just gives us a exception that doesn't really say much. We don't really know why, but behind the scenes, what you can actually do is just do the entire gradient, right? And then now we can just do gradients like this. So now we get an array, which the first value is the tensor, which is the partial derivative with respect to x. But then for the second one, we get none because of course we cannot calculate that partial derivative for y, okay? So that is the basics of variables. That's how you can create variables. That's how you can update them. And then that's also how we can do automatic differentiation using Tensorflow, which is something that to me is still really, really cool. It's mind-blowing. So in the future, we're going to do something a little more advanced, not calculating these simple functions here. In the future, we want to calculate the gradient of the loss function with regard to the model parameters. So we'll see how to do that. That's machine learning 101. We'll see how we can do that with TensorFlow as well in just a little bit here. As always, check the description below for the Python notebook so you can reference all the code, okay? So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.